welcome to my YouTube channel. So today I've got something special for you all, aspiring or experienced testers. I've put together an audio guide on the ISTQB Test Automation Syllabus, complete with sample questions to help you prepare for the exam. I used NotebookLM to generate this content, where two people are gonna talk about our syllabus, and I'm excited to share it with you. Whether you're just starting your certification journey or you're brushing up on your test automation knowledge, this audio resource will give you a head start. So sit back, relax, and let's dive right in.
Welcome to another deep dive. This time, it's into the world of test automation engineering. You're here because you want to learn more about how software is tested automatically, right? And what it really takes to build those testing systems.
Yeah, it's a pretty fascinating field.
We've got a ton of ISTQB Test Automation Engineering materials ready to go, syllabi, sample exams, even answers.
We'll uncover some pretty interesting stuff, that's for sure.
Yeah, like, did you know that even though it's all about automation, not every test can or should be automated?
Right.
That's something we'll dig into. We'll also talk about those nightly regressions, the ones developers sometimes mention. We'll explore how those actually work.
The whole software lifecycle perspective is super interesting.
It really is. Plus, we'll touch on the world of test logging.
Oh yeah, timestamps, correlation IDs.
It's like digital detective work.
It is. It's amazing how much goes on behind the scenes to make sure the software we use every day actually works.
It really is mind-boggling. So, let's get started. First things first, the big question. Why is test automation such a big deal? I mean, why can't we just have, humans click around and check if things work?
Well, you could. But imagine trying to test a massive application
Right.
with hundreds of features and across different browsers, operating systems, devices. Doing that manually every time a developer makes a change
Yeah.
would be a complete nightmare.
Yeah, I can see that getting old pretty fast. So automation is all about speed and efficiency then.
Absolutely. Automated tests can run thousands of scenarios overnight without needing a coffee break.
Right.
But it's not just about speed, though. It's about consistency, too. Repeatability.
Oh, okay.
Automated tests, they execute the exact same steps every time. So they eliminate human error. And you get those super reliable results.
Okay, makes sense. But wouldn't building all these automated tests be, super expensive?
Well, there's definitely an upfront investment. Yeah, no doubt about that. You need the right tools, people with the right skills, and a solid strategy to, guide your efforts. And this might surprise you. Not all manual tests are good candidates for automation.
Really?
Yeah, the ISTQB materials highlight this. Think about testing something like the aesthetic appeal of a user interface, right? That requires human judgment,
Right.
that sense of what looks good. It's hard to program that into a machine.
That's a really good point. I hadn't thought about it that way. So how do teams decide which tests to automate? Are there, specific criteria?
That's where the strategic planning comes in, which
Okay.
we'll get into a bit later. But some key considerations are how frequently a test needs to be run, how complex it is to execute manually, and how likely it is that, the part of the application being tested will change often.
Okay, starting to see the bigger picture here. So we've got the why of automation. Now, where does it fit into the whole software development process?
Well, that depends on the development model being used. If a team's using a waterfall model, testing typically happens towards the end, after the software is mostly built.
Okay.
But with Agile, you're testing continuously, alongside development as part of each sprint.
So an agile testing is baked right in, not an afterthought.
Exactly. And that means the approach to automation will be different too. Agile emphasizes component testing, ensuring each piece of code works before integrating it with others. It's like making sure each ingredient in a recipe is good before you mix them all together.
I love that analogy. So it's not a one-size-fits-all approach to automation then. Different test types, different tools for different phases of development.
You got it. Imagine all the different environments where software needs to be tested. You've got developers testing locally as they write code. Then there's the build environment where the code is compiled, the integration environment where different pieces come together, and so on. You even have pre-production and production environments.
Wait, testing in production? Isn't that risky? What if something goes wrong?
It can be done safely. Techniques like canary releases, they let you roll out new features to a small group of users first, almost like a test run in the real world.
So you're gathering real-world feedback before a full launch.
Precisely.
Mm.
But let's shift gears a bit. Let's talk about the people involved in all of this.
Okay.
Who are the key players in the test automation world?
Yeah, this is where I picture, the stereotypical coding wizards, right? hunched over keyboards in dark rooms.
Right.
Is it all super technical, folks?
Not at all. While you definitely need strong technical skills for sure, successful test automation requires a diverse team. You've got your test automation engineers, the ones who build and maintain the testing frameworks. That's the software that powers the automated tests.
So the framework is like the command center for all the automated tests.
Exactly. But it's not a solo mission. You also need testers, right? Testers who can design effective tests, developers who write the code being tested, and even business analysts who provide input from the user's perspective. And of course, you need project managers to keep everyone on track, make sure things are delivered on time and, within budget.
Wow, so it's a real team effort, and I bet the choice of tools depends heavily on the skills of that team, right?
You're absolutely right. If your testers are comfortable with coding, you might go for powerful tools, the ones that require scripting. But if your team is less technical, there are low-code or no-code solutions, which offer a more visual, user-friendly way to create tests.
It's really interesting. Okay, I think I'm ready to go a little deeper now, deeper into the technical side of things.
Yeah.
Can you give us a glimpse into the basic architecture of a test automation solution? Like, what are the building blocks?
Sure, let's think about a familiar app. Something like an online shopping cart, for instance. The app itself, the shopping cart in this case, is the system under test, or SUT for short.
Yeah.
That's what we're testing.
Okay.
Then you have your test automation framework, or TAF. This is like your toolkit for running your tests.
Gotcha.
It includes things like the testing libraries, any helper functions you've created, and the logic for executing the tests and reporting the results.
So the SUT is the app, the TF is the toolkit. What's the missing piece?
The connections between them. These are the ways the TF interacts with the SUT.
Right.
Might be through the user interface, using something like Selenium to simulate clicks and inputs.
Right.
Or it could be at a deeper level, directly interacting with the app's APIs, or even the database.
So it's like the TF is sending commands to the SUT and then checking if the SUT responds correctly.
You got it. And here's something to ponder. Even the code in your TF needs to be tested.
Oh, really?
Yeah, it's called TF component testing. And it makes sure all the tools and libraries within your framework are working as expected.
So it's testing the tests. Whoa, that's meta. It's like layers upon layers of testing. Okay, I'm starting to grasp the big picture here. But before we dive into the different approaches to building these tests, let's talk about testability. What makes software easy or hard to test automatically?
Testability is absolutely crucial.
So,
It's all about designing and building software in a way that makes it easier to test. Think of it like this. Imagine trying to fix a leaky faucet in a dark, cramped cabinet where you can barely reach the pipes.
No.
Frustrating, right?
Definitely. Give me a well-lit, organized space any day.
Exactly. Testability is like giving your testing tools that well-lit, organized space. It's about making the software's inner workings visible and accessible so your tests can do their job effectively.
So if I'm a developer, what can I do to make my code more test-friendly?
There are three key aspects to focus on: observability, controllability, and architecture transparency. Observability means you can easily see what's happening inside the software. Think logs, events, status indicators. Controllability means you can easily manipulate different parts of the software to set up specific test scenarios. And architecture transparency just means having clear documentation of how everything is connected, so testers know how to access and interact with different components.
So it's about making sure the software isn't a black box, but rather something that can be easily understood and interacted with by the testing tools.
Got it. Are there any specific tricks developers might not know about? That can make a big difference.
One cool thing is that some development frameworks, they can automatically generate what are called accessibility identifiers for UI elements. These identifiers make it much easier for automated tests to target specific buttons, fields, or other elements. It's like the framework is doing some of the testability work for you. That's awesome. Okay, we've covered the why, the when, the who, and the how testable of test automation. Now for the main course. Let's dig into the different approaches to actually building these tests. What are our options?
Well, we've got a whole menu of approaches to explore, from the simple to the sophisticated, each with its pros and cons. Let's start with the most basic one: capture playback.
All right, bring it on. Tell me everything.
Capture playback is just what it sounds like. You record your actions as you interact with the software, and the tool generates a script that can be played back to repeat those actions automatically.
So you're basically teaching the computer how to do something by showing it.
Exactly. It's a great way to get started with automation, especially for those new to the field, but it does have its limitations.
I'm all ears. Tell me more.
Capture playback tests, they can be pretty brittle, you see.
Brittle.
Yeah, if the user interface of the application changes even slightly, like say a button moves, or a field gets renamed, the recorded script, it might not work anymore. It's like trying to follow a treasure map where someone's, moved the X.
So maintainability becomes a big issue then.
Exactly. Imagine having to re-record all your tests every time the UI changes. That's where other approaches come in, like linear scripting. Instead of just recording actions, you actually write code to define the tests.
So this is where the coding skills come in handy.
Yes, definitely. Linear scripting requires knowledge of a programming language,
Right.
but it gives you a lot more flexibility and control. You can add logic to your tests, handle different scenarios, even connect to external systems if needed.
Yeah, I can see how that would be powerful, but also pretty complex to manage. Is that where structured scripting comes in? I'm sensing a progression here, like each approach adds more power and flexibility.
You're spot on. Structured scripting introduces the concept of reusable components. Think of it like building with Lego blocks. You create libraries of code. That can be used across multiple tests, making your test suite more modular.
Modular.
And maintainable.
So instead of writing the same code over and over, you create these reusable building blocks.
Yeah.
You can, assemble in different ways.
That's the idea. And this modularity, it makes a huge difference when dealing with changes in the software. If something changes, you only need to update the relevant component, right? Not like dozens of individual tests. The ISTQB syllabi actually have some great examples of how to structure test code for better reusability.
That sounds like a real time saver. But I'm guessing it requires more planning up front. You have to think carefully about how to design those reusable components.
Yeah, there's no escaping the planning phase.
Right.
But that upfront investment pays off big time in the long run, especially for large, complex projects.
Right. This is fascinating. Okay, what about data-driven testing? I've heard that term thrown around a lot, but I'm not quite sure what it means.
Data-driven testing is all about separating your test logic from your test data. You write your test scripts in a way that lets you run them with different sets of data without modifying the code itself. Imagine you're testing a login form, right?
Yeah.
You could have a single script that tests the login process.
Right.
But you could use data-driven testing to run it with different usernames, passwords, and maybe even different error messages.
So you're essentially running the same test over and over, but with variations in the input data. That's brilliant. Where does this data live? Are we talking spreadsheets, databases, what?
The data can come from a variety of sources. For smaller projects, simple spreadsheets or CSV files might be sufficient. For larger projects, you might use databases, or even specialized test data management tools, tools that can actually generate realistic test data for you.
That's really cool. And speaking of cool, what about keyword-driven testing? That sounds like something out of a spy movie.
Keyword-driven testing is a way to make test automation more accessible to people who might not be, programmers. It's all about defining tests using human-readable keywords, keywords that represent specific actions or validations.
Okay, I'm intrigued. Give me an example.
Imagine a test case for an e-commerce site, right?
Yeah.
Instead of writing like lines of code, you might have a test case that says something like open homepage, search for product, add to cart, proceed to checkout, enter shipping details, select payment method, place order, verify order confirmation.
Wow.
Each of these keywords is then mapped to the underlying code, the code that actually performs the action.
So it's like creating a set of instructions using plain English. That's brilliant. It really does open up test automation to like a wider group of people.
Exactly. Business analysts, domain experts, anyone who understands the business logic of the software can contribute to creating tests, even if they don't have coding skills.
Yeah.
The ISTQB sample exams actually have some interesting scenarios where keyword-driven testing is used effectively.
This is making me think of behavior-driven development, or BDD, which we talked about in a previous deep dive, I think. Is there a connection there?
Absolutely. BDD also focuses on using natural language to define the desired behavior of the software, typically in a given when-then format. And these scenarios, they can actually be used as automated tests, bridging the gap between business requirements and, technical implementation.
So it's like taking those plain English test cases and formalizing them into like executable specifications.
That's really neat. Okay, we've covered quite a few approaches here. Capture playback, linear scripting, structure and scripting, data-driven testing, and keyword-driven testing. Are there any other approaches we should be aware of?
There are two more that are worth mentioning, test-driven development, or TDD. and behavior-driven development, or BDD, which you just mentioned. But these are, they're more than just approaches to test automation. They're actually development methodologies, ways of approaching the entire software development process.
Okay, so let's talk about those. I've heard a lot about TDD, but haven't had a chance to really dig in. What's the core idea there?
In TDD, you write the tests before you write the code.
Whoa, really?
It might sound counterintuitive, but
It forces you to think about the desired behavior of the code up front, and it helps ensure that your code is, testable from the very beginning.
so you're defining what you want the code to do, then writing a test to check if it actually does that, and then you write the actual code.
Exactly. It's like setting a target and then figuring out how to hit it.
I like that analogy. So what are some of the benefits of this approach?
Well, TDD can lead to higher quality code from the start because you're forced to think about testability up front, right?
Yeah.
It also helps catch bugs early on at the component level
Yeah.
before they have a chance to, spread and cause bigger problems. And it can even improve communication between developers, testers, and business stakeholders, because the tests themselves act as a shared understanding of what the software should do.
So it's not just about testing then, it's about like a whole different mindset towards development.
Exactly. And BDD, it builds on this idea. By focusing on the behavior of the software from a user's perspective, it's all about collaboration, and ensuring that everyone involved in the development process is on the same page about what the software should do and how it should behave.
Okay, that's making more sense now. We've covered a lot of ground here, exploring all these different approaches to test automation. It's amazing to see how much thought goes into making sure the software we use is reliable and does what it's supposed to do. But there's one aspect I'm still curious about: test logging and reporting. What happens after all these automated tests have run?
That's a great question. Test logging and reporting might not sound as exciting as some of the other topics we've discussed, but they are absolutely crucial. They're how we make sense of all the data generated by those automated tests.
It's like the detective work phase, right?
Yeah.
Analyzing the clues to solve the mystery of whether the software is actually working as expected.
You got it. Let's dive into that world. So yeah, we've got all these automated tests running, right, generating tons of data.
How do we make sense of it all? Test logging and reporting, it sounds kind of technical.
Well, think of it like this. You've set up all these automated security cameras around your house. They're constantly recording. But if you never actually look at the footage,
Right.
what's the point? Right.
Makes sense?
Test logging and reporting are like reviewing that security footage. They help you understand what happened during your tests and identify any potential issues.
Okay, that's a helpful analogy. So what kind of information is captured in these logs?
Lots of stuff. Timestamps, for one. Knowing when something happened is crucial, especially if you're trying to, debug a complex issue.
Yeah, makes sense.
The logs also capture details about, like, the steps executed in each test, any data inputs or outputs, and of course, whether each step passed or failed.
So it's like a detailed history of everything that happened during the test run.
Exactly. And good logging goes even deeper. It can track things like system resource usage, CPU, memory, network activity, which can help you identify performance bottlenecks or potential memory leaks in your application. The ISTQB materials actually emphasize this, the importance of correlating test results with system-level logs to get deeper insights into performance issues.
Yeah, so you're not just seeing if a test passed or failed, but also why it might have failed by looking at what was happening in the system at that very moment. That's really powerful. But with all this information being logged, it must be overwhelming to sift through it all, right?
That's where different logging levels come in. Think of it like adjusting the zoom on a map, right?
Yeah.
Okay, you can zoom in for like detailed street level views or zoom out to get a broader perspective of the entire city. Logging levels, they work the same way.
Okay, I'm starting to see how this helps organize things. So what are the different levels?
Well, you've got your basic levels, like info for general information, warning for things that, might be a problem but aren't critical, and error for, well, errors.
Right.
Then there's debug, which provides very detailed information, useful for developers trying to track down bugs in the code. And for the truly hardcore, there's trace, which captures almost every single step and can generate a ton of data.
Wow, it's like choosing the right level of detail for the task at hand. Makes sense. Are there any particularly clever logging techniques you've come across?
One of the coolest is the use of correlation IDs. These are unique identifiers that are attached to a request as it, travels through different parts of a system. Imagine you're tracking a package being shipped, right?
Okay.
The correlation ID is like the tracking number. It allows you to follow the package's journey every step of the way.
So even if a request goes through multiple servers, databases, or, microservices, you can still trace its entire path thanks to that correlation ID. It's like a digital detective's best friend.
Exactly. And this is invaluable for debugging those complex issues, the ones that span multiple systems.
Absolutely. All right, so we've got all this valuable information captured in our logs. What now? How do we actually use this information?
That's where reporting comes in.
Okay.
Think dashboards, charts, graphs, anything that helps you visualize and understand the results of your test runs quickly and easily.
So it's about turning data into insights, right?
Okay.
Helping people make informed decisions based on the test results.
Precisely. And different stakeholders, they'll need different types of reports, you see. Developers might want, like, detailed reports on specific test failures so they can fix the code. Testers, they need an overview of pass-fail rates and trends over time. And managers are likely most interested in high-level metrics like test coverage and the overall progress of, the automation effort.
So tailored reports for each audience. And I'm guessing automation plays a big role here. No more manually compiling spreadsheets and sending them out via email, right?
Exactly. Modern test automation tools can generate these reports automatically, after each test run, and they can even distribute them to the right people based on their roles and needs. Some tools even offer historical analysis, letting you track trends over time and see how your test automation is evolving.
This is really impressive stuff. It's clear that building a robust test automation solution isn't just about writing tests. It's about the whole ecosystem, right? The tools, the processes, and the people.
Couldn't have said it better myself.
Yeah.
And it's important to remember, too, test automation, it's an ongoing journey, you see, a journey of continuous improvement.
So what are some key areas teams should focus on when it comes to improving their test automation?
Well, one of the most important is refactoring. Just like any code, test automation code can become messy and hard to maintain over time, right? Refactoring is the process of cleaning it up, making it more modular, reusable, and understandable. It's like decluttering your house, makes it easier to find things, and keeps everything running smoothly.
Spring cleaning for code. I love it. And what about speed? I mean, these tests can take a while to run, especially for large applications.
Yeah, optimizing execution time is crucial, especially in agile environments, where you need that fast feedback. Techniques like parallel execution, where you run multiple tests simultaneously, that can significantly speed things up. And strategically scheduling tests to run at specific times can also help maximize efficiency. The ISTQB materials, they actually provide some benchmarks for test execution times, which can be useful for setting goals and tracking progress.
So it's about working smarter, not harder. Are there any other tips for, getting more value out of our test automation investment?
Don't be afraid to add new features to your test automation framework, but be strategic about it. Focus on features that add real value, right? Integrations with other tools, enhanced reporting capabilities, or custom utilities that solve specific testing challenges that, you're facing.
So innovate, but don't overcomplicate. And what about keeping up with the latest and greatest tools and technologies? Is it important to always be on the bleeding edge?
It's a balance. You want to take advantage of new advancements, for sure, but you also don't want to constantly be chasing the next shiny object. Regularly evaluate new versions of tools and libraries. Weigh the benefits they offer against the effort required to, update. Sometimes sticking with a stable and familiar tool set can be the best approach.
So a thoughtful and strategic approach to upgrading makes sense. Any final words of wisdom for those, embarking on their test automation journey?
Test automation is a powerful tool, but it's not a magic bullet, right? It requires careful planning, a skilled team, and a commitment to continuous improvement. But most importantly, it requires a passion for quality. If you're truly dedicated to delivering high-quality software, then test automation is an essential part of your toolkit.
Well said. That was a deep dive indeed. We covered a lot of ground today. From the fundamental why of test automation to the intricate details of logging, reporting, and continuous improvement, I feel like I've gained a whole new appreciation for, the complexity and importance of this field.
It's been a pleasure diving in with you.
Thanks for sharing your expertise with us. Now, before we wrap up, I want to leave you with a thought. What are the biggest challenges you see in implementing or improving test automation in your own work? Head over to our forum, share your thoughts. Let's keep this conversation going. And if you're ready to go even deeper, we highly recommend checking out the full ISTQB Test Automation Engineering syllabi and resources. There's a whole world of fascinating detail waiting to be explored. Until next time, keep on learning and keep on diving deep.